Hello, everyone. My name is Fatima, and welcome to my demo on movie review sentiment analysis. In this project, I have explored different models to classify movie reviews as positive or negative. I'll walk you through the steps I have taken, the models I have built, and the results I have achieved. So let's dive in. The first, you can see that these are my libraries that I have uploaded. I have also uploaded with data preparation. I have used various techniques to clean and pre-process the texts in the data. This include converting making sure that there is no duplicates, there is no null values, also making sure that we have taken care of any converted any lower cases texts. We have removed stop words, and we have also applied lemmatization. We have also done some exploratory data analysis. As you can see, you have some histograms, some charts. We have some bar charts for distributions. We have some more graphs for polarities. After the data analysis, we have jumped into the evaluation procedure, where we, as mentioned earlier, we have used normalization techniques. I have used TF-IDF for feature extraction, which helps convert the text data into numerical features that machine learning models can understand. I have then split the dataset into training and test datasets to evaluate the model's performance accurately. Once the data was prepared, I was ready to experiment with different models. So my first model is my constant model, where my F1 was 0.0, I then proceed with the NLTK, TF, IDF, and logistic regression. For this one, I used NLTK for pre-processing, TF-IDF for feature extraction, and logistic regression for classification. It achieved an F1 score of 0.94 and 0.88 on the test set. And then I proceeded with my next model, which was aware. I used Spacey for text pre-processing and the TF-IDF for feature extraction, and again a logistic regression. It yielded the similar results, I believe. The F1 was 0.88, and the test set had an F1 of 0.87. Similar results for that. The next model we have is a space CTF idea with LGBM classifier. So in this, I incorporated Spacey and I utilized LGBM classifier. This model produced an impressive accuracy, and on the training, and 0.86 on the and the F1 score was 0.91, which is really great compared to other models, and the test set was 0.85. Finally, I used a more advanced model, which was BERT for embeddings. Although it scored perfectly on the training set with an F1 score of, let's see, with an F1 score. Oh, it was a perfect score, an F1 score of 1. And but the test set actually dropped to 0.72 from 0.86 compared to the previous model. So that's why I proceeded into the model evaluation. So I carefully evaluated each model using various metrics, including accuracy, F1 score, average precision score, and ROC AUC. While the traditional model performed consistently well, the BERT model struggled to generalize the unseen data, which is a common challenge with the deep learning models. I realized that BERT model was trained on a limited data set, which might have affected its performances. With more data and tuning, I believe this model has the potential to outperform the others. In summary, model 1, 2, and 3 performed really well, maintaining F1 scores above 0.85 on the test set, while Model 4 showed promise on the training set, but on the test set, it scored 0.76, which was lower our 0.85 range. But it requires further training for better generalization. So to demonstrate models' capabilities, I created a set of my own movie reviews. Um, and use the trained model to predict their sentiment. For example, when I inputted a review stating that I did not expect the reboot to be so good, the model predicted a high probability of a positive state sentiment. This application shows how these models can be beneficial in real world scenarios, helping users quickly gauge the sentiment of movie reviews or even other forms of text data. In conclusion, this project has been a valuable exploration of text classification using different models. While traditional models like logistic regression and LGBM classifier demonstrated solid performance, BERT showed potential, but I'm sure with the right adjustment, it could be a really good model. Moving forward, I plan to retrain the BERT model on the full dataset and explore techniques for mitigation overfitting, such as data augmentation and regularization. Again, this was just a very short demo, quick video of my project. If you want to know more details about it, please let me know. I'll be more than happy to share my knowledge of this project that I have interpreted it and analyzed. Thank you so much for watching. I'm excited to hear any feedbacks or questions you may have. Again, this is Fatima signing off.